Alright guys, we're on the next question now. I believe it's question 9. Let f be the function defined by blah blah blah. Okay, so it's trigonometry this time. I know we love trig. It says A, find the x-intercepts of the graph. Oh, okay. So, man, I wish the test was like this year. To find x-intercepts, guys, you make the equation equal to 0, right? And then you just solve for x. The equation, oops, computer does that. What's the equation? Sine x, well, sine squared of x. Okay, so we're going to make that equal to 0, solve for x. We can factor out the sine, make it a little easier, right? We're going to get something like this. Okay, so when sine of x equals 0, and when sine of x equals to 1. Okay, so sine of x is 0 at 0, pi, 2 pi, etc., etc. So 0, pi, 2 pi, etc. How about for when sine is 1? It's a pi over 2. That's it. Only one time in the interval from 0 to pi, and then after that, it's oh my gosh, 5 over 2 pi, I believe, etc. And then 9 over 2 pi. I think I'm right. I'm wrong with that. Whatever. I'm going too far probably. I forgot the interval. Oh my gosh, it's not erasing. What's going on here? There. What's the interval? From 0 to 3. Oh, I don't need this. Okay. And I don't need this one. Okay, so there's only 3 answers. X equals 0, pi, and pi over 2. Alright. So let's see. That was easy. Pre-calc questions, not bad. Let's hope and cross our fingers you get one of these. B, find the intervals of on which f is increasing. So let's see. F is increasing when the derivative is positive. So we have to first find the derivative. I have the equation here. So this is a chain rule, guys. Don't forget. Sine squared, that's a chain rule. So you bring down the 2, remember that? Take away 1, and then you multiply. You leave the sign inside, and you multiply by the derivative. That's how you do the derivative of sine squared. So 2 sine x cosine x minus cosine. And then make that equal to 0, and we solve for x. We could factor out a cosine. That makes it easier. So you don't actually need a calculator for this, which is what they're saying on the test. You don't need a calculator. It might mean this kind of problem is pretty straightforward. So cosine could be equal to, oh, right, cosine better. Cosine equals to 0, or sine equals to, what's that, 1/2? All right, let's think of cosine. Cosine starts at 1, so it's pi over 2, 3 pi over 2. I think we're done. We're good. We don't have to go further. How about sine is half? Sine is half at pi over 6, and then 5 pi over 6, and then the other 2 are negative. Okay, so those are the 4 different intervals. So we're going to go ahead and do that. Kind of like, it looks like the first derivative test, but we're not looking for relative min or max. Oh wait, this is bounded, right? It's from 0. So let me actually just do this. Make like a big block. 3/2 pi. And then we put the stuff inside the middle. So let's see, we have pi over 6, pi over 2, 5. Okay. So then they actually used one of the boundaries. So then, okay, so pi over 6, pi over 2, and 5 pi over 6. All right, so we have 4 regions. We're going to test values between each of these regions. Again, into this formula here, to the derivative function, and see if it's positive or negative. Oh boy. I'm just going to think of all students take calculus nonsense. So let's see. In the pi over 12, right? That's smaller than half. We know it's like, maybe, I don't know, like the answer is probably 1/4 or something. I don't know, some number. So it's positive here, and it's positive here, but then you're taking away 1. So I believe it's going to be half. I'm going to say it's negative. I need a calculator, but I'm pretty sure it's negative. How about after? So pi over 3 is bigger, obviously. Pi over 3 is radical 3 over 2, which is about 0.75. 0.75 minus 1 is still negative, and it's so it's still negative. You know what? I'm not sure. Think about this for a second. Ah, screw it. Calculator time. Pi, isn't it? What's the square root of 3 over 2? Let's find out, because I'm not sure. Oh, wait a second. I'm dumb. Square root of 3 over 2 divided by 2, and then obviously it's multiplied by 2. It's just square root of 3, which is 1.5. 1.5 minus 1. This is a positive. And okay, so it's positive. I was thinking, yeah, because it's trig. It shouldn't have weird things like that. Okay. Like, I expect this. This is what I'm expecting when I see trig. I expect a wave. But I wasn't. That's why I was a little worried. Let me see. After pi over 2, what can I plug in? And it's before 5 pi over 6. So, oh my gosh, my brain today. What's that number I'm thinking in my head? 2/3 pi, right? 2/3 pi would be that. It's in the second quadrant, so it's going to be negative, and then it's going to be positive. Screw this calculator, because that's going to be, okay. It's going to be negative here, right? 2/3 pi, but then here it's going to be, let me just do it. Sine. My brain today, guys. I'm sorry. Well, lately. This whole coronavirus thing, let me see. Where's my mode on radians? Yes, it is. Let's see. 2 times sine of 2 sine 2 pi. Come on. Over 3 minus 1. Oh, it's positive, so it's bigger. Okay. So it's negative and positive, so it is negative. That was correct. And then, of course, something bigger than, let's say pi. Okay, that's an easy one, right? So cosine of pi is negative. Sine of pi is 0. So it's, and then 0 minus 1 is negative. And then a negative times a negative is a positive. So that's correct. Okay, so my suspicions were correct. So there you go. So I was expecting that kind of bouncing. So then we'll say f is increasing. I think there's no e, yeah. Increasing when 5 or 6 or oh, wait a second. Increasing. Sorry, between these two. When x is between pi over 6 and pi over 2, or 5 pi over 6 and 3 pi over 2. Okay. And you're done with that one. That one's, the trig sucks, I get that, but it's not too bad. Alright, let's see. Find the absolute maximum value of and the absolute minimum of the value of f. Justify your answer. Okay, so to find the absolute max, you need to test the boundaries and you need to test the critical values. This is the extreme value theorem that guarantees an absolute minimum max, provided you have a continuous function. Continuous from A to B, right? So let's see. I'm going to go ahead and put the x values. X values are, what are the boundaries? 0, 3, actually I'm going to do this, put way down here, 3 pi over 2, like that. And then we're going to put in between, in this section, we're going to put all the critical values, which are pi over 6, pi over 2, and 5 pi over 6. So I know that the graph starts at 0, starts going down, then goes up. So I know for a fact, then goes down and then goes up. So I have a feeling that the absolute max is going to be the last point. Excuse me. Well, we're just going to go ahead and test it out. I'm going to leave it like that. So sine of 0, and then 0, sine of 0 is 0, so 0 minus 1 is negative 1, but 0 times anything is 0, so it's 0. Pi over 6 is 1/2, right? So 1/2 times negative half is negative 1/4, I believe. Pi over 2, sine of pi over 2 is 1. So 1 minus 1 is 0, so it would be 0. 5 pi over 6 is 1/2. So it's also negative 1/4. Yeah. And then 3 pi over 2. Oh boy. Negative 1. So it's positive 2. Yeah, I think I did it right. I'm just trying to to really just, rack my brain. Although, what's the question asking for? Find the absolute max value and the absolute min value. Justify your answer. So, I guess this is my justification. So we can say the absolute max is 2 when x equals 3 pi over 2. Absolute min value is negative 1/4 when x equals 2 pi over 6 or 5 pi over 6. I think that should do it. Alright, so that's it for this question. That was a pretty simple one. Hope you guys understood everything. I'll see you guys later.